Hello, I'm Ethan, and in this video I'm going to teach you Keyhole. Keyhole is a technique that you can use to save moves during F2L when one of the two pieces in a pair is already solved. After that, we'll learn how to use Keyhole to solve two F2L pairs at the same time, which is called pseudo-slotting. So let's get started. You can use Keyhole during F2L to solve a corner if the edge is already solved, or to solve an edge if the corner is already solved. But to use Keyhole, you need to have another empty F2L slot for inserting the unsolved piece. For example, in this situation, this slot has one edge solved. Its corner is here, and this slot is unsolved, so we can use this slot to solve the corner. Firstly, we need to move the spot where the corner needs to go into the unsolved slot using a D move. So in this case, we'll do D. Next, we need to insert the corner into the unsolved slot. It doesn't matter how you insert the corner, as long as it doesn't disturb any of the other three pairs. But here are the most efficient solutions. Also remember you can mirror any of these algorithms if you need to insert the corner into the left slot. So if white is on the side like this, we can insert the corner with R, U, R'. If white is on the front, insert the corner with U, R, U', R'. And if white is on the top, insert the corner with R, U2, R', U', R, U, R'. Then all we need to do to solve the F2L pair is undo the D move from the beginning. If you want to practice more of these, scramble the cube, solve the cross, and solve one edge into the middle layer, then you can practice inserting the corner with Keyhole. If the corner is already solved and you need to insert the edge, you can use a very similar idea. Firstly, we need to move the unsolved corner underneath where the edge needs to go, using a D move. Then we need to insert the edge. If the colour on the front of the edge does not match the front centerpiece, we can insert it with R, U', R'. If the front colour of the edge does match the front centerpiece, we can insert the edge with U', F', U, F. Again, if you need to insert the edge into the left slot, then just mirror one of these two algorithms. Then we can just undo the D move from the beginning to solve the F2L pair. Again, if you want to practice more of these, you can scramble the cube, solve the cross, then solve one of the white corners to set up to a Keyhole insert. Keyhole can be very useful for making an X cross. If I solve this cross with F2 R' D', I can see that this corner will end up down here, with white on the bottom, which means it will be solved. The corresponding edge is up here and will not move when I do the cross. So if I just do F2 R', this slot is still completely unsolved, so I can insert the edge with U', R, U', R', then do the D' to align the cross, and that makes an X cross. But for now, this technique should only be used if you have planned it in inspection. If you can't track the unsolved piece during inspection to see where it will end up, you'll need to either turn slowly during cross and track it with look ahead, or you'll need to stop and look for it, both of which are not ideal. So to start with, only use Keyhole to make an X cross if you've planned all of it during inspection. But with a bit of practice, and with good look ahead, you might be able to solve an F2L pair with Keyhole without needing to plan it beforehand. If you've been playing around with Keyhole for a while, you might have noticed that a Keyhole insert always moves a corner piece and an edge piece. More specifically, if you want to insert an edge, it also affects the corner in the unsolved slot. And if you're trying to insert a corner, it also affects the edge in the unsolved slot. So if you have a corner solved in one slot and an edge solved in another slot, you can just do a D move and solve the remaining corner and edge to complete both F2L pairs at the same time. This is called pseudo-slotting. Don't learn pseudo-slotting unless you are very comfortable with Keyhole, otherwise this won't make sense. You'll also need to be able to look at an F2L case and immediately know how to solve it using advanced F2L. Finally, recognition for pseudo-slotting is very difficult, so it's even more important that you only use pseudo-slotting if you've planned it during inspection. So if you look at the scramble here, you should see that I have two F2L pairs solved, one pair with just the corner solved, and one pair with just the edge solved. The remaining corner and edge are in the top layer. I'll switch to another cube to make this all easier to visualize. So if we do a D move, you can see that the locations for solving the last corner and edge make an F2L slot. So we can make these two pieces into something that looks like an F2L pair, called a pseudo pair, and then insert it into the slot with F2L. Now all we need to do is recognize which F2L case this is, so that we can solve it with an F2L algorithm that we already know. To figure out which case this is, we need to identify the orientation of the edge and the orientation of the corner. We can easily recognise the orientation of the corner by looking at where the white sticker is. But for the edge, we need to identify if it's a good or bad edge. I've already covered edge orientation in this video, but basically, if you can match the side colour of the edge with one of the side centres, it's a good edge and you can solve the case using only R, U and L moves. Otherwise it's a bad edge and you need to rotate before solving the case. So here this edge has red on the side, which matches with this side centre, so it's a good edge. The white sticker on this corner is here on the top, and the edge is a good edge over here, meaning this is the same as this F2L case. So we can solve the pseudo pair in the same way as we would solve that case. Then we can undo the D move from the beginning, and now we've solved two F2L pairs at the same time. Pseudo slotting is very difficult, so I'll show you another example now. If you look at this scramble, you can see that I have two F2L pairs in the back solved, this front edge is solved, and this front corner is solved. The remaining edge and corner are here. So firstly, we need to identify if this edge is a good edge or bad edge. This edge has blue on the side, which does not match either of the side centres, which means it's now a bad edge. So we need to rotate so we can turn it into a good edge. The corner is over here, with white on the top, and the edge is here, meaning this is the same as this F2L case. So we can solve the pseudo pair in exactly the same way. Then we can undo the D move from the beginning. What's interesting is that pseudo-free pairs don't look paired up since the colours don't match. This is a pseudo-free pair ready to insert with R, U', R'. And this is a pseudo-free pair ready to insert with R, U, R'. So it might be quite useful to memorise what these free pairs look like so you can spot patterns while planning a pseudo slot during inspection. If you want to practice more pseudo slot examples, you can do it in the same way I showed for regular keyhole inserts. So that's it for this video. If you enjoyed it, please subscribe by clicking the button down here. Thanks for watching.